Okay, hi, I'm Masashi Nojima on Tokyo University Science. Today, I will present about development of a meteoric solution ion source. On this YouTube session, I will firstly introduce the principle of this work. And second, I will show you the working instruments separating the mass and also creating focusing meteoric solution ion beam. And finally, I will show you the result of mass separating the power and its applications using this apparatus. Okay, going on here shows the principle of meteoric solution ion beam. This technique utilizes two important basic principles. One is electrospray ionization technique, which is so famous for the Nobel winner Professor John Benfan. The ESI technique can be applied for all liquid materials, also into vacuum environment. On this work, we introduce the meteoric solution into vacuum for ESI method and filters on their own weight using newly developed two rotating field mass filter. This graphically shows the principle of two rotating field mass filtering. On the first rotating field, mass filtering are slightly occurred on this trajectory. But in the second field, the phases are opposite and the mass separating are accelerating to this axis. Yes, this axis. Okay, this is a working instrument of a developed rotating electric field mass filtering system. You can see the nice pattern through the iPhone screen. These patterns show the mass-separated trajectories focused on the front screen using MCC price. And these nice patterns are operated from the separated view screen connected to the HDMI cable to this monitor. You can recognize the centered annual rings and also flower-like fringes. This is my student is operating the axis of the mass filtering system on this monitor. Here shows experimental conditions. Three different samples are prepared. One is control sample, which is mixture of ethanol and DEBGE, and second 0.05 molar cobalt nitride hydrate. Third, 0.1 cobalt nitride hydrate. Rotating speed of electric field witness frequency needs defined as below 300, 350, and 400 kHz each. Generally, a typical charge mass converts to the center on typical frequency. But this work, we didn't specially define typical frequency of mass from these frequencies. Here shows the result of mass patterns on different solutions on each frequency. On the solution maps on 0.05 molar, the images are tending to be not so clear. This was caused by different ESI conditions on low emission current. Also, same black spots on images are originated to injured fluorescent screen. So, we compare the ring shift on each frequency. We can find similarities on same frequency of different solutions. Also, we can find differences on the images on 350 kHz, especially near the center. we try to make clear the central ring using computing simulator trajectory. We divided to 5 bands of images on 350 kHz. The bands 1, 2, and 5 are matched on control and solution sample. The band 3 and 5 seem to be appeared on the existence of cobalt ions. These bands are originated to cobalt and molecular compounds generated on each ESI process. So we export the central ring to silicon wafer. We are expecting to contain cobalt metallic solution on it. We export 3 picoampere ESI beams to silicon wafer 92 hours on keeping the frequency of 350 kHz. The center of the ring area concentrated cobalt contained ESI beam exposure. The silicon wafer was transferred to TOF-SMITH instruments and obtained element maps scanning large area by bismuth primary ion beam. The cobalt element map appears ring pattern by rotating electric fields. Also, silicon element maps reveals interactions with ESI beams. We can say metallic solution ion beam can be generated by ESI process and two rotating field mass filtering technique. So I want to summarize my talk. First, I will introduce the principle of metallic solution ion beam, also working state of its instruments. We have found the metallic solution ion beam was generated by ESI method, and also cobalt-contained ion beam was purely filtered and generated cobalt fingerprint on silicon wafer. That's all.